In this module, we will focus on the security vulnerabilities associated with JSON Web Tokens, JWT. JWTs are widely used in web authentication and serve an important function in many applications. However, they are also a target for various cyber attacks, including token manipulation and signature bypass. It's essential to understand these vulnerabilities to effectively safeguard your applications against such threats. Through this course, you'll gain a comprehensive understanding of these potential risks and learn strategies to mitigate them. JSON Web Tokens, or JWTs, are a fundamental component in web authentication mechanisms. They are commonly used to secure interactions between clients and servers, especially in API and web applications. However, their widespread usage makes them attractive targets for cyber attacks, including token manipulation and signature bypasses. Understanding the security vulnerabilities associated with JWTs is essential to protect applications from these types of attacks. By gaining insights into how JWTs can be compromised, we're better equipped to implement robust security measures that help prevent unauthorized access and maintain the integrity of our systems. Let's focus on the core components that make up a JSON Web Token, JWT. Understanding this structure is essential for managing JWTs effectively. A JWT consists of three parts: the header, payload, and signature. The header typically includes the type of token, which is JWT, and the hashing algorithm being used, such as HS256. The payload contains the actual data or claims that you wish to communicate, like user identifiers or other relevant information. In our example, the payload includes a user ID and a name. Finally, we have the signature. This part of the JWT ensures the integrity of the token. It combines the header and payload, signed using the specified algorithm to prevent tampering. The signature is what keeps the data secure and verifiable. Notice in our example JWT how each section is represented: the header, the payload, and how they are converted into a specific signature string. Understanding these components lays the foundation for recognizing vulnerabilities and strengthening your web security practices. Now that we understand the fundamental components of a JWT, let's explore potential vulnerabilities with the JWT signature. One key concern is the algorithm confusion attack, where an attacker changes the algorithm in the header from RS-256 to HS-256. This can be executed using a command such as python3 jwttool.py jshs256-p public key. Another critical vulnerability is the none algorithm attack, where the algorithm is set to none, essentially allowing an unsigned token to be accepted. Both these vulnerabilities highlight the importance of implementing strong validation checks for the algorithms used in your JWTs to ensure security. On this slide, we're examining command examples for altering the JWT signature algorithm from RS-256 to HS-256. The first command utilizes OpenSSL to connect to a server and extract the certificate chain into a file named certificatechain.pem. Subsequently, the public key is extracted from this certificate chain using OpenSSL once more, outputting it to pubkey.pem. Finally, with the public key in place, the jwttool.py script is employed to change the algorithm of the JWT to S256, specifying the newly obtained public key. This command sequence is pivotal in executing an algorithm confusion attack by switching from RS-256 to HS-256. In this slide, we are focusing on two main vulnerabilities: JWKS spoofing and manipulation of the KID parameter. JWKS, or JSON Web Key Set, is a set of keys that can be used to validate the signature of JWTs. By modifying the JU header field in a JWT, an attacker can redirect it to a malicious JWKS URL under their control, allowing them to spoof the keys and manipulate the token verification process. Additionally, the KID parameter can be exploited if not properly sanitized. An attacker could introduce a path traversal payload, such as //pasty, to execute unexpected queries or access restricted locations within the system. These vulnerabilities highlight the importance of robust validation mechanisms for the JKU and KID parameters to prevent unauthorized token manipulation. In this slide, let's look at practical exploitation scenarios. These scenarios highlight vulnerabilities found in JWT implementations. The first scenario deals with exploiting the none algorithm. This involves identifying JWTs that do not enforce signature verification, which could allow an attacker to manipulate token contents without being detected. The second scenario focuses on the use of weak secret keys. Here, attackers can perform brute force attacks using tools like Hashcat to crack weak or commonly used secret keys. An example command for this brute force attack is shown, utilizing the rockyou.txt word list to systematically uncover weak passwords. These scenarios underscore the importance of implementing robust security measures in JWT handling to prevent exploitation. In this slide, we focus on defense strategies and best practices for handling JSON Web Tokens, or JWTs, securely. First, it's paramount to ensure proper signature verification. Any algorithm chosen must be implemented securely to avoid vulnerabilities. Prefer using strong secret keys and consider asymmetric algorithms like RS-256 over HS-256, as they offer enhanced security benefits. Additionally, validate JWT claims rigorously. Parameters such as the issuer, ISIN expiration, XP, should always be cross-checked against expected values to prevent unauthorized access or token misuse. These best practices are essential to maintaining the integrity and security of JWTs in any application. In conclusion, JWTs, or JSON Web Tokens, are incredibly powerful tools for managing authentication and information exchange securely. However, they can easily be misused if not handled correctly. Key takeaways include the importance of strong verification processes and secure deployment practices. Vigilant management of these tokens is necessary to maintain security. As for the next steps, it is recommended to practice exploiting JWTs within a controlled lab environment to better understand potential vulnerabilities. Additionally, keeping up with the latest updates in JWT standards and understanding evolving attack vectors will enhance your ability to mitigate risks effectively. This approach will ensure that your JWT implementation remains robust and secure.